In my last video, I covered determining the price of lunar-derived products from the amount of energy it took to get it, but I didn't go into much detail on the system itself. So in this video, I will explain the principles of energy accounting. Energy accounting is a process of keeping track of the total amount of energy spent to make something from regolith, through its entire refining and manufacturing process to the finished product, including the energy needed for prior prerequisite processes, such as iron beneficiation. Say you want to make a metric ton of steel. You'd need to see how much energy it took to move the necessary amount of regolith to yield a metric ton of iron from regolith, the amount of energy needed to refine that amount of regolith, the amount of energy needed to get the other alloy metals, and finally the energy needed to smelt that iron into steel, and the energy spent to send that metric ton somewhere, giving us the total cost. That is energy accounting, the total amount of energy spent on something. However, energy accounting only works for purely automated setups. People cannot directly be involved in the process, as you need to give them a paycheck, which cannot be accounted for in energy usage. They can certainly manage and administer the operation, but cannot be directly involved in the processing or moving materials. Energy accounting is essentially accounting, but with a whole lot more energy meters to keep track of electricity usage, enabling us to determine the price of a lunar material. But why should we do energy accounting? Well, the reason is simple. On the moon, it will enable us to determine the potential cost of things. If we know how much each material costs to make a ton of it, and we know how much mass of each material are needed for construction, and the other smaller but equally important details like energy cost of each weld, will enable an operation to accurately budget its energy consumption for the lunar day and night, if it's operating at night. However, such a setup will generate so much data that it'll be impossible to keep track of it all, even on a small scale, requiring a bunch of automation, which wouldn't be too difficult, nothing more complicated than a Google spreadsheet or Excel collecting data. Such a setup will be necessary to not be overjealous or confident on how fast or big you can build on the moon. Energy accounting will allow you to more accurately understand how much you can produce and how fast you can build a project. Along with that, it will enable you to figure out how long it will be until your energy return on energy investment goes into the positive for a power production method, such as solar electric power, nuclear power, solar thermal power, whatever you're considering to use. You can even rank them accordingly if you know how much energy each one requires to be invested for a kilowatt hour or more of energy to be produced, enabling you to make the best possible decision you have for power expansion, or plan along those energy timelines. Energy accounting can let you know how disastrous things went for the operation from a recent meteor strike annihilating the oxygen farms, ruining the local vacuum. It will also let you compare different methods of mining, refining, or logistics to see what works best for your current capabilities or goals, letting you answer questions such as, is it worth it for us to invest into the reflector array for this 100 kilowatt hour thermal regolith battery that can provide power for the entire lunar night, or should we just go for a nuclear reactor? Or what are the differences in energy investments per payload launches between a mass driver and a rocket for exporting to low lunar orbit from the lunar surface? Overall, energy counting is important for lunar development, as without it, if you don't know what is actually worth the effort and what is a waste of energy, and if you don't bother to slap an energy meter on everything that uses electricity, then lunar development is destined to fail. So please, spend that extra 10 kilowatt hours of energy to mass produce and install an energy meter. Next video, I'll actually be showing you energy accounting by explaining the math of calculating how much energy is needed in total to produce a metric ton of iron from lunar regolith. So please, like, subscribe, and leave a comment as an offering to our algorithmic overlords.